This is the real Tom Rose, and it looks like we've got a inequality where we're going to have to do some fraction manipulation, but be careful what you don't. That my first instinct usually is, let's take this fraction, we'll multiply both sides by that, and we'll just cancel out a bunch of things, and we'll be good to go, right? So multiply this by 0, everything cancels out, and we just have 2x plus 1 is greater than 0. Be careful. Generally speaking, when you're working with inequalities, you want to be really careful about multiplying and dividing by variables. And the reason why is because you might remember the other rule, which is if you multiply or divide by a negative number, you have to flip the sign. Well, when you multiply by a variable, you don't know whether you're multiplying by a positive or negative. So you might have to flip the sign, or you might not. So if you don't know, you can't do that. So you want to be very careful of it. So one of the things that I'm going to do here to protect myself is I'm just going to, sometimes you have to do it, and it creates a headache. But what I'm going to try to do is look for things that I can do before I do that. So, and I actually spotted one. So this is x squared minus 4, which is a difference. It's a subtraction between two perfect squares. So if you have a squared minus b squared, for example, that equals a plus b times a minus b. You need to memorize that formula. The test is really smitten with this particular code, so make sure you have that really well memorized. So I'm going to apply that. So we get 2x plus 1 over x plus 2 times x minus 2 is greater than 0. And unfortunately, I'm not seeing any way around this. I really don't want to multiply by a variable, but there's not much I can go. I thought I was going to get lucky with this factor, but I'm not getting lucky. So what we need to do is we're going to have to multiply by that. So what that means is it's a big headache for us, because what we need to track is whether this is positive or negative, and if so, in what range. So this function x squared minus 4, it looks like it's a quadratic, and it looks like this. And it's positive. If you're not sure, you could plug it in your calculator, or you could plug values into it and kind of like draw that chart in your head. But it's positive when x is greater than 2, and it's negative when x is less than negative 2. Sorry, positive whenever it's bigger than 2 and less than negative 2. So here are the areas where it's positive, and then there's this one little range where it's negative. So what we need to say is, in the world where if x is between, write it like this, if negative 2 is less than x is less than 2, so this is the world where x is negative. And why am I doing this? I'm doing this because in that world, we need to flip the sign when we multiply by the denominator, right? So if that's true, then what we get is 2x plus 1 is less than 0. It's the same as multiplying both sides by this stuff and flipping that sign, because we multiplied by a negative number, right? We know it's negative because it's negative in that universe. So then what you get is 2x is less than negative 1, and x is less than negative 1/2. So x is less than 1/2 if s is less than negative 1/2 if x is in this range. Yep. And we also have the universe where if x is not in that range, so all other times, so if x is less than negative 2 or x is greater than 2, in that world we end up with 2x plus 1 is greater than 0, which is just the same function with the denominator missing, right? You multiply by the denominator, it cancels out with the 0. So then you get 2x is greater than negative 1, or x is greater than negative 1/2. So this is super complicated, but we need to combine all 4 of these constraints. And I have to draw a number line to keep track of this. So basically, the places that we need to keep track of are negative 2, negative 1/2, and positive 2. So x is less than 1/2 in this range, so inside negative 2 and 2, x is there, and x is greater than negative 1/2, but only in this range, which is when x is outside of that. So I need something negative 2 to negative 1/2, and x is greater than 2.